Hey folks, this is Paul here. I'm just making sure my audio is working because I've made some changes. So give me a hot second. Uh-oh. Why, what is wrong with me? I'm really bad at computers. How about now? Oh boy, I think I'm working. I just think my settings are wrong. So one of the joys of this Linux machine is my audio is always changing its output to be something I'm not running. Aha! All right. My audio is working. Great. So welcome. This is my usual Thursday afternoon stream. Ordinarily, I do a co-stream with JJ from IBM, but he is off doing his own thing today, which means I'm also doing my own thing. I was going to stream with my buddy Mario, but he is also missing in action. So it is just me. So I thought we were going to do some Java stuff, some Spring on Kubernetes stuff, but given I am far from being a Spring expert, I've decided to suddenly change what I'm doing. And I thought I would look at this right here, which is HashiCorp has a way to use HashiCorp Vault as a secret backend for Kubernetes. I have not played with this before. I think TGIK did an episode on this a while back. If you want to go back and watch that after we're done here. But I'm just going to go ahead and have a play around with it and see if we can get it working. I'll run it up in a kind cluster, I hope, and see where we get to. So they have a tutorial, and I've been told that the HashiCorp tutorials in general are really good. So it'll be fun to run through it. And then obviously it is an open source project, so it is up here on GitHub. And so we'll work between the two and see where we end up. So let's pull up. All right, let me drop that down. Make it bigger, just to make my life more exciting. I've also just changed editors. So I have been using VS Code, and I just switched to VS Codium, which is the non-Microsoft packaged version of the open source VS Code. So it's just got a couple more Fs in the levels of freedom, as you might say. So I'm just playing around with it, but I haven't really done any kind of setting up. So any extensions and stuff, I'll need to figure out as we go along. So hopefully it won't be too painful. This is a kind config that I just grabbed from another project of mine that I figured we would start with because it has some port mappings. So if we need to, we can get to a faux ingress. It's got 2 workers and a control plane. It is fairly recent Kubernetes 1.18. I think if I comment out the image, I'll get 1.19, but I've had some issues with that because of the new version of Go. It doesn't like certificates that only have a common name and don't also have a list of DNS hosts, and that tripped me up on some other stuff. So I'm going to avoid that. Probably wouldn't be a problem anyway, but easier to just avoid it. So here's my cluster. Hopefully this is all going to work. I did notice just then that they mention using Minikube. Where did I see that? Minikube down here under prerequisites. We are doing kind, and so we'll see where we go. And then if we get desperate, apparently there's an online terminal, an online tutorial, so we can always play with that if we need to. So, oh, this is good. Look at this. This tutorial was last tested on this date on this platform. More tutorials, documentation, etc. needs to have a statement like this. I've even seen somewhere they'll actually give a warning at the top of the document if like the actual age of the document is more than say 6 months. So I feel with like documentation, especially for newer stuff like this, by the time 6 months is through, it ain't gonna work. So being able to see that right away and knowing if you're going to be in for a good time or not is useful. And yeah, so they're showing the Docker version, Minikube version, Helm version. So this is all pretty good. Install Minikube. I'm hoping we don't need to do that. We have kubectl. We have Helm. Let's just have a look. So I guess it'll tell us to start our kind cluster. So we'll go ahead and do that. Kind create cluster config. Oh boy. Kind delete cluster. And then create again. All right, so that's going to take a hot minute. And my poor machine is getting really... Oh, my screen. You'll want to see the big screen. There we go. Now you can see what I'm doing. I'm sorry about that. Right. Well, I hadn't really shown anything anyway. So here's my kind cluster. Here's my kind config that I talked about before. So you can probably see things better now. Here is my command line, and I think the terminal size looks pretty good here. Let's just maximize it up. Ooh, not entirely. It's cutting off the bottom. We'll get most of it. Like so. Maybe we'll try not to get too much covered by me. All right. So that's happening there. So we have to install HashiCorp's Vault, obviously, because that's how HashiCorp's secret storage system. So we'll go ahead and get started on that in a second. So while this is running, I'm running this on my Linux laptop. Is running Ubuntu 20.04. I recently just changed back to GNOME 3 or GNOME 3, how are you supposed to say it? I have been using XFCE for the longest time, but its support for newer stuff is getting really long in the teeth. So doing network device management, and then trying to do any sort of Thunderbolt port management is just horrible on XFCE. And even things like changing from headphones to not can be janky. So I took the leap. I have a GNOME 3 extension that gives me 4 workspaces. So this is kind of my usual like documentation up, code up, and then consoles. That's just kind of my general way of working. Yeah. So my kind cluster is up. So let's make sure we've got Helm at a reasonable version, 3.3.0. I think 3.3.4 just came out, but this is good enough. So let's go ahead and get Helm installing HashiCorp's Vault. So we have to add their repository, and then I think we do a Helm repo update to go and update all the things. And then we're going to Helm install. We're going to set a couple of things. So we're going to set to being a dev server. That'll probably drop off a bunch of needs for PVCs and stuff like that. So let's go ahead and run this. So this is clearly not going to get us a production grade Vault, but that's okay. Now that finished real quick, and that finished real quick because Helm doesn't stick around waiting for it to fully complete. It just passes on the resources to Kubernetes. Now I already made one mistake. I should not have put this in the default namespace. I wonder if that's going to come back and bite me. We're only a second in, so let's just go ahead and delete it. Reinstall it. Namespace Vault, and then I think create namespace. All right, so there we see namespace vault. So I'll change into the vault namespace and then helm status vault. That's nice. In the notes they've given us this. So helm status vault, which just kind of gives us what we just saw anyway. Helm get vault will not do what they think it will do. So there's an interesting. So I'm guessing they mean helm get vault all. Helm get vault helm get all. Yeah, that's what we wanted. So there we go. There is an update we could do there. Is this in? Let's have a look. Search helm vault helm templates notes. Okay, so interesting. So they've updated, look, 28 days ago they updated this. So this is what they wanted me to do. Helm get manifest vault. Yeah, okay. So it's interesting they obviously haven't released this to their Helm repository yet. But at least I don't have to get distracted making a pull request to fix it up myself. All right, so here we are. We are here. Yeah, Helm repo, Helm install, get pods. Get pods. It looks to be up and running. Looks to be healthy from the logs. So now we're going to set a secret. And we're going to do that by executing into the Vault pod and then using the Vault CLI to set a secret. So I guess in a more real world, you would have the Vault CLI and you'd be authenticating locally. But just for the sake of demo, we're executing into the pod like this. So go ahead and execute in, and then we can create secret. We can now make sure that we have that secret. That looks good. And then exit. Now we could also, now that we have done that, do something like that, right? Which means we could, if we wanted to, do something like alias vault equals that. And then vault kv get secret db pass, right? So that's a pretty cheaty, hacky thing I just did, but it gives us the equivalent of having the Vault CLI locally, even though it's really just Xing into the container. So what are we going to do next? We are going to configure Kubernetes authentication. So Vault provides a Kubernetes authentication method that enables clients to authenticate with a Kubernetes service account token. Kubernetes resources that access the secret and create the volume through this method through a role. So we need our interactive thing, but because we did the Vault alias, I think we can just do this. So that was successful. This here won't work though. So we will actually, will it? I think it'll try and run this locally, not in the container where it does that cat, etc. So we'd better jump in. Thought I was being clever, but I wasn't. So what are we doing? We're getting a JWT token from the Kubernetes service token, and then we're just setting some details, right? Okay, so basically creating a kube config, right? Because it's our host, a CA cert, etc. We'll go ahead and do that. Success. The environment variable, blah, blah, blah. For the Kubernetes secret store, CSI requires it has read permissions of all mounts and access to the secret itself. So we're going to write out a policy. So vault policy, sysmounts read, sysdata dbpass read. Okay, we're going to go ahead and do this. Let's copy our screen. Whoops. There we go. Success. And vault extension only supports the key KV secrets engine. This extension verifies the requested secret belongs to a supported engine by reading the mounted secrets engines. Data KV v2 requires an additional path element of data is included. Okay, whatever that means. This is, I think, the HashiCorp KV secrets engine, not the Kubernetes secrets. So next we create a Kubernetes RBAC role named database that binds this policy with a Kubernetes service account named secret store CSI driver. Right. So we have done that. The role connects to this kube service account, secret store, CSI driver, and the namespace default with the vault policy internal app. Right, so I need to make sure I'll be back in the default namespace. Yeah, so I should have probably, if I was doing this for real, I would have created use your words, Paul, a namespace to put this into that wasn't default, and then I would change this up here to be that namespace. But since it's asking for default, let's just switch back to default. Oh yeah, exit out of there. Change the default namespace, looking good. What are we doing? Add the secret source CSI driver Helm repo. Okay, so they actually have their own repo for it because it's coming straight off just to get stored. File, all right, let's just roll with that. So we've done that, and then we install it. Oh, we are back in the default namespace. Yes, we are. So that again, that's happened pretty quick. We get this command that we can run to see where we're at. Container creating, and then they've used notes well because they've put this in here, telling us how to create a secret provider class and move on. So that's pretty useful. All right, so our CSI driver is running 3 of 3. So I'm guessing that is daemon set that's running one on each pod? Yes. Right, so it is a daemon set, and its node selector is OS equals Linux, and I have 3 nodes, 3 worker nodes. Cool. Okay, so that's looking good. I wonder if this is going to bite me, not having put Vault in the default namespace. We'll find out. We will find out. All right. So we're grabbing this, basically as a here doc, and applying it. It's a daemon set that installs the provider vault executable for the. All right. Go ahead and run that. All right. This is a classic. This is why you don't just copy and paste the whole thing. So usually if there's a $, people are trying to tell you that there's also some output. I totally missed that. So let's try that again. That probably actually applied anyway. Okay, get ds. Yeah, okay, that applied anyway. Just tried to run a command that didn't exist at the end, which is fine, right? So we get our pods. Okay, get pods, and we will see. Oh no, I didn't update the stream name. Ah, what a clown. Oh well. Hey Tiffany, hey Mario. You were supposed to be here, Mario. I had to roll without you. All right. Let me see what we just did. We just did this guy right here. Provider Vault is running and ready. There was only one of them, right? Okay, good. So there's actually 3 of them running, whereas the doc here only shows 1 of them running. And that is because they're doing Minikube with just 1 worker, whereas I'm doing Kind with 3 workers. I know, Tiffany. Mario is a disappointment. He was supposed to join me and he didn't. Maybe he tried to, but it was too late. Oh well. Sorry, Mario. I had to roll and I didn't have time to wait. And now I'm not hooked up with Zoom or Skype or anything, so I can't bring you in. Sorry, buddy. All right, so what did we just do? Now we're going to do kubectl exec. And we get the name. Okay, so it's going to run this, which is going to get us the name of the pod that we want to use. And this is important because it's coming, the pod is coming from a daemon set, so it doesn't have a definitive name. And so you can see it's picking the first one of those pods. And so when I run this command here, it'll use that name to allow me to exec against it, and it will stat that file. Right, that looks right. Interesting. I wonder if this is like dumping it on a host path. Let's have a look at this fella. K edit ds Yeah, see, we got a volume with a host path of etc Kubernetes. And so I'm guessing it's loading this up and then it's copying the binary into there, which is effectively getting it onto each of our worker nodes. If you had a cluster with pod security policies, or you had like an OPA, Open Policy Agent gateway, checking for people doing dodgy stuff, you would probably fail at that host path, and you'd probably need to create either a specific pod security policy for this fella, or make an exception in the OPA rules, or you would need to find an alternative way to get that file copied up into the appropriate directory on your worker nodes. Right, so that was that. So I bet you if I do this, so Docker PS, so here's my actual kind cluster. So if I do Docker exec -ti bash, and then I look at that, what was that directory? Secret store, providers, vault. So there we have that file. So that's exactly what we expected to happen. And I can do a stat of that. And that's going to be the same result as what we saw when we did the exec into the pod. So that's a good sign that things are working as expected. Okay, so the Kubernetes secret store CSI driver is an operator, or it at least extends the Kubernetes API to provide this secret provider class. So we could do kget cluster, no. API resources. And then secret provider class. Yeah, so you can see here where it has extended the Kubernetes API with CRDs. And if we wanted to know more about that specific one, we could do kubectl explain blah. And that'll basically give us what it is, what fields. And of course, this isn't particularly useful because it's an object. So we can then do -recursive. And now we can kind of see, okay, spec takes these, but I don't think it's super recursive. Oh no, it is. It's just that this is an array. Oh yeah, I get it. So secret objects is an array of data, which is an array of keys and object names. So it does recurse through the spec. Not particularly easy to read. I wonder if you can get that into like YAML or something. Nope, that's all right. Let's not get too sidetracked. So yeah, that's that CRD. Configure requires the IP address of the Vault server, the name of the Kubernetes authentication role, and the secrets. Aha, so this vault address is going to be different for me. For me, I'm going to need to do vault.vault. So let's go ahead and grab this and stick it in here and change this to be vault.vault. The rest looks the same. Okay, yeah, and you see the objects, the DB path and password name. So that is about what we expect to see. I created. All right. So the Vault database secret provider class that we just created describes one secret object, and we have, whoa, what? That's unpleasant. Yeah, okay, fair enough. They're links. I won't do that again. Object path, name, and version. These link to a secret that is in Vault. So I guess this is the thing that creates our secret. And so I bet you we have a secret now. Okay, get secrets. Oh no, we won't have a secret because it's not actually using Kubernetes secrets. It's using the CSI. So I should have kept on reading. Oh, let's make sure that this. I mean, we kind of just already checked, but oh, who didn't pick up my typo? What is this? Amateur hour? Amateur hour at the Kubernetes hut? Valut. Let's try that again. Okay, that looks better. I'm surprised it didn't give us any kind of errors or anything. All right. So now we create a pod with secret mounted, the secret stored in Vault, authentication configured, and role created, the provider Vault extension installed, and the secret provider class defined. It's finally time to create a pod that mounts the desired secret. So we're going to create this pod here, web app. We don't need to change a host name or anything. Nope. All right, so let's go ahead and run this. Nope. Copied. Oh. Nope. All right. I'll do it the hard way. All right, so let's look at this fellow right here. The container, whatever that is, doesn't really matter. Here's what we're looking for. Volume mount is name secret store. It's being mounted to secret store read only true. And then the volumes, aha. See, in the volumes here, we're now calling the CSI for the secret store. And we're giving it the secret provider class Vault database. So that links it back to this fella. Cool. So now we can get pods. Pew, pew, pew. CSI secret store, provider, Vault, web app. So web app hasn't started. And it's saying it should be started. Oh boy, crash, loop, back off. Okay, logs, web app. Okay, pods. Okay, describe pod web app. Okay, so it thinks it started. It did crash at some point. But maybe that was a crash because it was taking time to get the volume up. Okay, status there is now running. Nope, crash loop back off again. Okay, logs. So it's not giving us a lot of hints as to what's going on. Now it's not clear. if it's the app itself that's broken or the mounting of the app. So what can we do here? Well, we have a pod. So let's grab this pod description, and then so I need some sort of image with bash, and then we give it a command of sleep, args of say like 12, like a long time. Command. I think you have to fully spell out command. I guess we can probably just do Ubuntu and see what happens. Oh, let's wrap it up in this fella right here so it's easier to apply. Oof. All right. Oh, we need to give it a different name. Debug. All right. Okay, you get pods. Watch that. Nope. We'll watch this. All right, so debug is running. So now I should do kubectl exec-ti bash, and then have a look at here. Okay, so this is telling us that despite that web service crashing, that's not the cause of, like, the secret itself isn't the cause, because we're seeing it here that we just mounted into the debug pod, and we're looking at it. It's called dbpass, and it contains the db secret password. So it is, in theory at least, working. Let's have a look at these pods. So jump out of here, get pods. So let's have a look at this web app gizmo. Oh, too far. So let's have a look what this app is. Docker.io. You know, they've changed the URL to the Docker hub so many times, I never remember what it is. Let's look for this guy. This guy. Go web server that prints hello world. I mean, how is this crashing? From Alpine, add web, Docker file, hello world. I can't even why this is crashing. But also it's not actually using this secret. Oh, okay, so they're just... He's not even using that app. Like, come on, fella. So why... I mean, it would be much better off running something like this, but... or like run Apache and like mounted the secret into like the HTTP path or something. All right, but anyway, that's it. So we now have our secrets, and we're accessing them via disk versus the secrets resource. So what is this buying us? I think what this gives us is we don't actually have the secret on disk anywhere, but like on the host, it's a fake volume created by the CSI driver. So the only places the secret exists is in Vault and also in this pod. Now I would guess that if we wanted this to be a bit more secure, we would need to maybe use RBAC rules to determine what pods can access what secrets. Yeah, it'd be interesting to figure your way through that and figure out, okay, how do I make sure? Because as you saw, I just created a bash and said, go grab this secret. And I didn't have to provide any other details. So if I have kubectl access, even just basic like read and create and delete pods, or read and create pods, I can still mount someone else's secret. So I feel like this doesn't fully solve the secret problem without also wrapping some kind of RBAC around it. I guess if this guy has a service account, and then we could tie that service account to which secret provided classes that user has access to, that's probably how you would do it. Okay, well, I guess we can call that done. It was pretty successful. Is there a place I can report a bug? I guess asking forum. Nope. Okay. Well, I think that'll probably do. We got it working. I would like to figure out how to report that bug with the web app, but it's not obvious how to do that. So I might chase some folks later on and see if I can help them. Either see if I'm doing something wrong or if they need to update it. But I think that's a good place to end. Nice, quick, well, fairly short stream. Hopefully you all got something out of it. I certainly did. I have not played with this before, but I've certainly been interested in it for quite some time. And yeah, let's wrap this up. So goodbye. Thank you for watching, and I'll see you again real soon.